There have been some questions coming up about this term net force and what exactly does the term net force mean. Net force, we're using this word net to mean the sum of the forces. So what we're talking about is we're talking about adding all the forces together. That's what this word sum means. We're talking about adding forces together. Well, how can we do that? How can we add forces together? How can we add them up? Well, we've talked a little bit about vectors in terms of velocity and acceleration. Well, forces are also vectors and they have direction. So I've illustrated here, I've put on here a 150 Newton box. This is just a box. I didn't try to get fancy and draw it three-dimensional or anything. Here's a 150 Newton box. Now the Newton is a measure of force, and the capital N there represents Newton. And this is a measure of force. It's what we call the SI unit for force. Try to be a little bit neater in my writing here. It's the SI, or the International Unit, that stands for System International. It's a French term, but International System. It's the SI unit for force. And because this is a 150 Newton box, that tells you that there would be a force vector. Let me use a different tool here so that maybe I can get a nice straight line for us. And let's pretend that this box is on the ground. So it's sitting here on the ground. And because gravity is acting on it, there would be a force vector pushing down. Well, it's the force of gravity. What's it equal to? It's a 150 Newton box, and so the force of gravity must be 150 newtons. Now, net forces means we're adding forces together, and I've illustrated down here the formula that force is equal to mass times acceleration. Now, mass is the amount of matter in an object, and acceleration is how its velocity is changing. Now, you know that if we put a box on the ground like this, and the ground is level and it's just sitting there, it's not going anywhere. Its motion is not changing. Well, how could its motion not be changing? Here's a 150 Newton force pushing down on the box. Why isn't the box accelerating in a downward direction? What's going on here that it's just staying put? And you know this is how things operate, because you put things down all the time and they just stay put. Well, the explanation in physics is this, is that underneath the ground that this box is sitting on must be pushing back with a force. It's pushing with an upward force equal to 150 newtons. So now you have a 150 Newton force pushing in one direction and a 150 Newton force pushing in the other direction. And in this situation, the net force, if we add them together, the net force equals, and let's say that up is the positive direction, 150 newtons. So we're going to say this is positive 150 newtons, and this sign shows direction. If up is positive, down must be negative, plus, and we add them together, plus negative 150 newtons. Well, this equals 0. So the net force is 0, and because the net force is 0, this object doesn't accelerate. Sometimes we put an N down here to indicate that we're talking about net force, or the sum of the forces. Now, just to give you a little bit of something to go on here, let's find a nice color here. let's say that a person comes along and go give this box a handle, and let's say that they push on this box, and they push with a force of 100 newtons. And for right now, let's just say that there is no friction. Let's say that this is a frictionless surface, so we don't have to worry about friction in this case. No friction on the ground. It's zero friction. This surface is what we call friction. It doesn't really exist. We just pretend that it exists for the purposes of talking about our problem, but we say it's frictionless. It has no friction. Well, now what's the net force? Now let's make this the negative direction. Let's make this the positive direction. Well, now this is a positive 100 Newton force. Well, if there's no force over here on the other side pushing back, and this person is pushing with 100 newtons, it's pretty easy to see that net force, or actually I could use the start using the abbreviations here so you get used to seeing them. The net force equals 100 newtons, and it's positive. It's in a positive direction. And we haven't done this yet in class, but you can see that, this is going to make this object start to move. The object is now going to accelerate in the positive direction. Okay, I'm not going to calculate that right now, but let's say there's another person on the other side of the box. And maybe you've done this with a friend or something. Just to illustrate our point, we'll make it a smaller person. And let's say that this person is pushing back in this direction with a 50 Newton force. And now look at the direction they're going. This is going to be a negative 50 Newton force. Well, now let's calculate the net force. So now it's going to be different. I've changed the situation because now the net force equals, let's add them together, we have a 100 Newton force that's in the positive direction plus a negative 50 Newton force that's in the negative direction. So now our net force in this case is going to be 50 newtons. Well, this is still a frictionless surface. That means that the object will accelerate, but I'll try to draw it here, but it means that the object is going to accelerate less. The acceleration of the object is going to be less than it was in the first situation because now there's another person pushing back in the opposite direction. Notice that none of this changed the upward and downward net force situation. In terms of up and down, it's still zero, and so the object still stays at ground level. Hopefully this explains net force a little bit to you and helps you bring some understanding, but I think what can be confusing is we're not used to using this word net in this way. We think of it like fishing or something, but what net really means is the sum of. So we're talking about net force, we're talking about the sum of the forces. So you have to figure out what they all are and add them together to be able to determine whether an object is going to accelerate or not.